Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll study about insulator, conductor and semiconductors. Before we start understanding properties of semiconductor material, it is very important to revise about the valence electrons. The electrons in any atom in outermost orbit are known as valence electrons. We know that energy level is maximum in the electrons which are in the valence band. These valence electrons can be travel to the conduction band when we apply certain energy to the valence electrons. Then free electrons. The external energy equal to forbidden gap energy must be applied to make valence electrons free and to move them to conduction band. The electrons in conduction band are not confined to any atom and are known as free electrons. For the conduction of current in any solid metal, that is because of presence of the free electrons in the conduction band. So, presence or absence of free electrons in solid or any substance decide whether it is an insulator, it is conductor or it is a semiconductor. So now let us see the classification of the substance. Any substance can be divided into major three categories. One is insulator, second that is conductor, and third one that is semiconductor. Now we'll see one by one the property of each classification of the substance. We start with the insulator. Insulator cannot conduct the electric current. Conductor can conduct the electric current very easily. And the new category of the substance, that is semiconductor. The conductivity of the semiconductor is less than conductor, but it is greater than insulator. Now let us study each category in detail. In case of insulator, we have as usual valence band and we have conduction band. The gap of energy between a valence band and conduction band, that is known as a forbidden energy gap. And the gap in case of insulator is very high, almost equal to 8 electron volt. Glass, mica, etc. are the examples of the insulator. Valence band is completely filled with electrons and conduction band is completely empty of electrons. Forbidden energy gap in case of insulator is very high and it may have energy gap of several electron volt, and that is approximately 8 electron volt. Because of this very high forbidden energy gap, in case of normal condition or in case of normal application of electric field, electrons cannot be free from the valence band and they cannot travel to the conduction band. So there is no free electrons are available to constitute electric current in conduction band. But in case of very high electric field if applied or very high temperature is observed, in that condition, very few electrons can travel to the conduction band and act as a free electrons. The next category, that is conductors. Again, we have valence band, we have conduction band. In case of conductors, valence band and conduction band are overlapped to each other. Aluminum, silver, copper, etc. are the examples of the conductor. Valence band and conduction band both are overlapped to each other, and there is no forbidden energy gap. So, because of absence of forbidden energy gap, valence electrons can easily travel to the conduction band and can act as a free electrons. So, large number of free electrons are available to constitute electric current in conduction band. And the next category, that is semiconductors. In semiconductors also, we have as usual valence band and conduction band. We have forbidden energy gap in case of semiconductors also, but the level of energy gap, that is very less, and that is approximately equal to the 1 electron volt. Germanium, silicon, etc. are the examples of the semiconductor material. Valence band is almost filled with electrons and conduction band is almost empty. So in normal condition, there is no free electrons in the conduction band and it cannot conduct the electric current. Forbidden energy gap in case of semiconductor material, it is very small, and that is approximately equal to the 1 electron volt. Under ordinary condition, no free electrons are available to constitute electric current in conduction band, but because of very small forbidden energy gap, in case of room temperature also, because of heat energy is imparted to the valence band electrons, the valence band electrons can travel to the conduction band very easily, and then they can act as a free electrons and conduction of the electric current is possible. So thank you for watching my video. Keep watching. Thank you very much.